In question 14, you're asked to factorise and then sketch the graphs. Now, before I can do that, I should really locate my y-intercept, which of course is going to be at the origin. We'll state it. I'm also going to have the general shape like so. That may help a few of you. There's not going to be a stationary point of inflection because it will factorise quite readily. So I'm going to find my zeros or my x-intercepts. Which becomes x squared into 9x minus 2 is equal to 0. So I'm going to have a double 0 at the origin, or turning point, and at 9 to 0. I now have enough information in order to sketch that graph. Not a lot of details required for a graph like this. Like so. A neat little question though to start off this exercise. In the next question, I've quickly listed the y-intercept and the shape. In order to find the zeros of the x-intercept, I've got to take out a common factor. So therefore, that happens when that's equal to 0. And therefore, x into 9x squared minus 4 is equal to 0. Now, very quickly, I can find the fact that this is a difference of 2 squares to help me there. And I've got enough information in order to perform the graph sketching. So my graph will look like so. Now, in the next problem, I like rewriting that so we've got the overall shape factor happening, and I can more readily factorise it. Look, it's not that easy to factorise. I had to trial and error, so therefore x minus 3 is a factor. And it then becomes a matter of factorising it. So that gives me x minus 3. And I'll have to have an x cubed and a 1 happening there. After a bit of trial and erroring, we can see that that factorises to negative x minus 3 lots of 3x squared minus 1 is equal to 0. So that's actually a perfect square, believe it or not. So that becomes root 3 x minus 1 lots of root 3x plus 1 equal to 0. So therefore, x is equal to 3, x is equal to 1 over root 3. The answers might say root 3 over 3. And x is equal to negative 1 over root 3. Now, it's a bit of a ballpark as to where 1 over root 3 is. It's about 0.56. 0.58 I should say, and about negative 0.58. So that gives me enough information in order for me to be able to plot the graph, or sketch the graph I should say. So x and y, I'll have a 3, I'll have a positive 0.58, I'll have a y-intercept of negative 3, and I'll have a negative 0.58. So a graph will look a little like so. Slightly unusual, but definitely worthwhile persevering with. In this last case, I could do something about the shape. It should be x squared. Shape is going to look like so, and it looks like it should have 3 zeros. The y-intercept is going to be at the origin, or 0, 0. The zeros, or the x-intercept, to factorise that. And that comes down to x plus 3, lots of x plus 1 equaling 0. So I'm going to have zeros at 0, -1, and -3. And that becomes a relatively easy one to graph up. 3 zeros, 3 cuts. We don't, of course, have to find the turning point in this instance. Like so.